All right, my growth mindset, math, math side, maniac panthers. Here we go. Polygons in the coordinate plane. Here's a little song for you to help us with this lesson. Once upon a time, there lived an origin, 0, 0. That's where we begin. Just two little motions get us to the end. Left and right and up and down, that's X and Y, my friend. First comes X, side to side. You might go left or you might go right. Then comes Y, up and down, up above the sky, down below the ground. That's all you got to do for this. So let's plot these coordinates. Here we go. -5 and 3. First comes X, side to side. I like to color coordinate my axes. Watch this. Ready? Let's get some axes color coordinated in here. Boom! We got blue going up and down. That's vertical. Up and down. That's the Y. We got red going left and right. That's horizontal. That's going to be our X. So first comes X, side to side. You might go left or you might go right. But we're going to start the origin, remember? Once upon a time there lived an origin, 0, 0. Right there it is, right in the middle. This, right where the crosshairs meet. 0, 0. First comes X, side to side. You might go left, you might go right. This negative tells us we are going to go left. So left 5 units. 1, 2, 3, 4, 5. There's our first point. But now, then comes Y, up and down, up toward the sky, down below the ground. We're going up toward the sky because this is a positive. That means we're going up. And we're going to thin this line out just a titch. Boom, boom. Here we go. We're going to go up how much? 3. A 1, a 2, a 3. See, this corresponds with our blue. This red here, this corresponds with our red going here. Yeah, see? Beautiful, beautiful. There's our first point. Let's plot that in black. And I'm going to do the next 3 really quick, like. Okay. So now that we've done that, where is going to be the 4th point? Let's connect these dots. So far, and if we were to make a rectangle, where would the 4th point go? Can we put it over here? No, here? No, here? No, 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 no. We're getting closer. There it is. Look at that. What is this point? First, let's start the origin. Once upon a time, there was an origin. 2 little motions get us to the end. First comes X, side to side. So what's our... we can go backwards. Let's pop this down. Let's go straight down in red. Where does that land? That lands on that 4. For this point here, it lands on the 4. So that's going to be our X. Now, what's our blue? Hike, blue, 42, 45, 6, no, 7, it's 5. If you go straight across this way, you're going to land on that 5. So there it is. Boom, there it is. Boom, there it is. Ah, bop, boom, there it is. Next question. Okay, I'm going to plot these points really quick, the first 2. Okay, so what are we going to do now? What they want us to do is see if we have these 2 points here. We want to know where can we put a 3rd point and get a right triangle. Well, let's start doing some trial and error, shall we? Trial. That's funny, triangle, trial. Okay, go to 8 and 12. I'm going to plot some points and we're going to see if we can see something and figure something out here. Okay, does 812 give us a right triangle if we connect these dots? No, that's a straight line. That's not going to work. So, no. Sorry, not that one. Okay, do these make a right triangle if we connect these dots? Oh, boom, bada bang, bada bing. Yes. Okay, here we go. We did it. It's a triangle. But no, they wanted a leg of a right triangle. This is not a right triangle. Next. That's going to be a no. What do you think about this one? Is it going to make a right triangle? So, have you picked up on any patterns yet of predicting which one of these will be and won't be? Looking at what we've done so far. Oops, I thought I had a marker there. That's back. Looking at the ones we've done so far. From here to here. What are the ones that are yeses have in common? Here's a yes. Here's a yes. Oh, they have 12s. I bet you that has something to do with it. Let's keep going. As a matter of fact, let's test it. Let's test the one with a 12 and see if that works. Let's test this one with a 12 right here and see what happens. Well, I'll be darned if there it is. I think it's going to work. I think, you know what? Because every time something lands on that 12, on that up and down line here, it will form a right triangle no matter where you put it. Like if you put it up here, whoosh, right triangle going up. You put it down, way down negative something on the net, but it's a 12. It's 12. Oh gosh, watch this out. Ready? It's 12 is the x, and then our negative value is -7, and it's still going to make a right triangle. Let's pop it in here. Watch this. Ready? So put it. Oh, here we go. So if you go from this point all the way down and connect this one, and just so you can see it better, I'm going to do it in green. Here's the triangle we just made. Right here, it's still a right triangle. So anything on that 12 line makes a right triangle. Is that the only way we can make a right triangle? Is anything on the 12 line? Is there another line on here that no matter where we put a point, it'll make a right triangle? Yeah, there is. Have you figured out what it is yet? Let's do it here. Okay, so I think it's going to be anything with the, see here, our first dot that we did is all on the 12. The x value is 12. You're not moving side to side anywhere, right? You're only going up and down. That's the only thing that changes. So I'm thinking anything here on this 4 is going to also make us a right triangle. We're not going side to side at all. So our x stays the same, which is going to be 4. Here the x stayed the same, was 12. But we can change our up and downs. Our y value, our up and down value can change. And no matter where it goes, it's going to make a right triangle. Let's test it out with this point right here. Start with this 8 and this 4. Go to 4 and now go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Let's see. Does that make a right triangle? Yes, it does. I'll do one more to prove it to you. Do I need to really? Because anywhere we put it, you can see it. Let's try, okay, 4 and 2. Here's 1, 2, 3, 4. 1, 2. It goes with 4 and 2. I'll do it with a different color. We'll pop the green out. Right triangle. Even if you put it up here, we'll do a red one. Anywhere up here will also make a right triangle going up. Done. Get it? Got it. Good. Next. That was a long one. The area of this triangle. I love this kind of question because you can sort of guess what the area is before you even find out for sure. A 1, a 2, a 3, a 4, a 5, a 6, 7, 8. That's almost 9. A 10. And let's see, I'll say if you put this one and this one together, you're going to probably get close to another one. And if you put, like, say, this one and this one, that's going to be another one. So I'm estimating that we're going to have probably 1, 2, 3, 4, 5, 6, 7, 8. Again, this one and this one will make 9. And this blue one and this blue one will probably make 10. It's going to be close. Oh, 10, I'm sorry, and 11, 12. Somewhere near about 12 units squared. But let's do the actual math. How do we do that, pray tell you? Well, I'll show you. Okay, we'll use the formula and see what happens. Area of a triangle. Formula is base times height divided by 2. We'll use this as the base. We'll use blue as the height. And count off the base for us. 1, 2, 3, 4, 5, 6, 7 units is the base. So I'm going to fill it in over here. Area equals 7 times the height, which is 1, 2, 3, 4. And we're going to divide that by 2. So 7 times 4 is 28. So I'll put a nice little purple 28 on the top. So our area is going to equal 28 divided by our 2, which equals 14 units squared. And I thought 12, so I was kind of off a little bit. But at least if I know if I had an answer like 140, that was not even close. Or if I had an answer choice that was 3, I know that's not even close. 12 is kind of far, but not super far from 14. So I'm not too unhappy with that. Let me just double check that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Yep. 7 times 4 divided by 2. If we were to draw this out as a full on rectangle, we would have this. And that would be 7 times 4 divided by 2. We would take half of it. We would want the half that's in the blue. So beautiful this stuff is. Next. Perimeter. It's the distance around. You have to imagine a little kitty cat. Meow. Perimeter. It's the distance around a polygon. Perimeter. It's the distance around a polygon. Watch this. Ready? Here, kitty, kitty, kitty. Purr. How many units is it around there? Well, there's 1, 2, 3, 4, 5, 6, 7. There's 8 units. Let's put an 8 there just to be safe. 8 units for the perimeter so far. I want you to comb the perimeter, make sure everything's okay. Okay, kitty, kitty, keep walking. All right. Okay, kitty, kitty. Go. Perimeter. There's 1 more unit, 2 more units, 3 units right there. Okay. Keep going, kitty. Meow. I'm upside down, meow. Be quiet, meow. Just do your job, meow. Meow, okay. 1, 2, 3, 4, 5, 6, 7, 8. Oh, that makes sense. 8 on the top, 8 on the bottom. Because this is a rectangle. Opposite sides are equal. So do we, kitty, need to really go? We know it's going to be 3, right? Meow, I want to go. Let me go. Be quiet, kitty. Be quiet, meow. No, meow. Yes, meow. All right, we'll let you go, kitty. I'm a dog person, but we'll still let you go. Thank you, meow. Okay, ready? 1, 2, a 3. Oh, lo and behold. Let's put it in there. Add them all up. What's the total? 8 plus 8 is 16. 3 plus 3 is 6. So let's put it all together. 16 plus 6 is 6 and 6 is 12. And 22. 22 units. Now it's not squared because these are just one-dimensional, not 2 dimensions. Haha. Okay, so I did this the drawing way, the visual way. How could we do this using the formula? I'll show you. Okay, so here, when the y values are the same, we don't really need to do anything with those now, because that's not going to really make a difference in what we're doing. Speaking of making a difference, we're going to find the difference between the x values. What's the difference between 11 and negative 10? What you would do is we're just going to say this is x1. We'll call it x. This is x2. It's so much fun, like the X-Wings, you know, in Star Wars. Okay, so anyway, x1's 11. Let's say x1 minus x2 will give us the distance. Let's try it. Ready? x1 is 11 minus x2, which is negative 10. Ooh, what does that equal? Well, when you put two negatives together like this, I'm just going to keep it simple and tell you. I'm not going to get into it in detail too much. Let's just turn that into a positive. Two negatives equal a positive here. I do not want you to eat. That means I do want you to eat. All right, just think of it that way for the moment. That's 21. That's what we got. 21 units. Works every time. Next. Oh, peace. Oh, Panthers, pride, passion, purpose. We did it.